Hello Kotlin Whispers. Welcome to the first lesson in our practical test-driven development with Kotlin 2.0 course. In this series, we'll build a real-time chat application that runs on Android and desktop using Compose multi-platform. It will also have a Ktor backend. In this lesson, we'll explore the project structure, set up our testing tools, and write our very first server-side test. We'll learn using a TDD approach called red-green refactor, a framework that helps developers to build a test suite, write implementation code, and optimize their code base in short development cycles. The red-green refactor approach helps developers compartmentalize their focus into 3 phases. The red phase is always the starting point of the red-green refactor cycle. The purpose of this phase is to write a test that informs the implementation of a feature. The test will only pass when its expectations are met. The green phase is where you implement code to make your test pass. The goal is to find a solution without worrying about optimizing your implementation. Finally, in the refactor phase, you're still in the green, but you can begin thinking about how to implement your code better or more efficiently. To follow through this course, clone the repository provided in the description. I have opened MindAmp in IntelliJ IDEA. Our project will focus on 3 main folders. The server folder, which contains our Ktor backend, client folder, which contains our Compose multi-platform Android and desktop app, and our shared folder, which contains common Kotlin code for both platforms. We'll write our server tests in the server module. We'll write our client test in the client common test module. This will be shared tests. We can open the application Kotlin file inside the server's main source set. This is how it looks. Since this video will be primarily focused on writing our first server test, we will not look at the client until the next one. For now, you can run the application by pressing the play button. Once the server starts running, we can check our primary route. There we have it. Hello Java 17.0 from Ktor. This template comes with minimal dependencies. Let us check what we have and add what we need for test-driven development. Let's navigate over to our server's build.gradle Kotlin script. Currently, we will see we have our shared project, logback library, Ktor server core, Ktor server netty engine, the server test host from Ktor, and test JUnit. If we look at the definitions of these libraries in our libs.versions.toml file, this is how they look. Here are our dependencies. Server core is mainly for the core Ktor server functionality on the JVM. Then add the netty JVM engine, and also let's add server test host that will run on our JVM. This will be the dependency that will allow us to run tests on Ktor server. While the entire application will be created using the TDD approach, client test dependencies will be added later. Let's start by creating our very own test folder inside our server module. We'll have it in Kotlin. Within here, let us also add our package which will store our tests. I always like matching the package names, so I will use exactly what I have in my main. Awesome. Now, we will write a test for a ping endpoint that returns the text pong. This endpoint doesn't exist yet. Our test will fail initially. Let's add a new file. Let us start by defining our test. we will need to mark it with the @test annotation. Lastly, we will need to define our test. Let's do that. We have successfully written out our test. What have we exactly done? Since we're in a Ktor application, the server test JVM dependency gives us the test application Lambda function. This allows us to build up an app equivalent to our Ktor server. Within here, you can add in all the modules that we would like. In our case, we will add module, which is what we have defined in our application file, after which we will call our client using the client property provided within test application, make a GET request to the URL called ping, after which when you get back a response, we are confirming that the text has pong, and we are also asserting that the status code is 200. If we run this test, we expect it to fail. As expected, if we look at our message, our assertion actually fails. And this is because we do not have that endpoint yet. Let us now go over into the green, and this will be implementing the actual ping route. We are back in our application file, and within our module, inside our routing, let us add a new route. This route will call ping, and it will respond with a text called pong. We can rerun our test. Now the test passes. The final phase with our red-green refactor is the refactor stage. Right now, the route is inline in main. As the app grows, we'll move routes into separate files for clarity purposes. For now, we will leave it here. This is fine. We can confirm that our actual implementation works by opening the browser and looking at the ping route. Let's go back to Firefox. You can see when we call the ping route on a browser, it returns the text pong. We will connect the client to the server later. For now, the server works just as well. Android and desktop code will be added in a later video. So, what have we just learned? Firstly, we've looked at a project structure for which we will go through our course with. Number 2, we have added server dependencies for our TDD approach. Lastly, we wrote our first failing test. We implemented the minimal code required to pass the test, and we are yet to refactor though. In the next lesson, we'll write a proper login endpoint using TDD with authentication logic and tests for success and failure. See you.